We are live, sir.
Okay, great. So, yeah, guys, good evening, everyone. I hope you all are all ready for this session. So, welcome everyone to one more amazing session of this data structure and algorithm. Yeah, this you can say this would be the last session of theory class, and we would be discussing some concept of queues, which I said in the last session that we'll be continuing in this session. And yes, that very important thing, and the thing which we all are waiting for, competitive coding. So we'll be discussing some questions about this competitive coding, guys. So yeah, good evening Asta, good evening Shoaib, good evening Kari. Yeah, if I have taken your name correctly, if I have taken your name wrong, then pardon me. Okay, then, guys. So let's start this. Let's move on to our discussion. So yeah, what was the last thing we discussed? We discussed about queue. We discussed about Enqueue operation, Enqueue, right? So I'll just quickly share your screen. Basically, that same old whiteboard where we scribble around and see things. So let's get to that place, and let's scribble more things there. Just give me a moment. Okay, so there is already something there which we had discussed in the last session. So yeah, it's even good for having a revisiting thing, right? So this is Enqueue, right? We had discussed Enqueue. So I hope you already remember this thing. Okay, so we would check for the overflow condition first. Okay, then we would go for if let's okay, so if first we'll check overflow. If it is not overflow, then what we do, we'll check if the queue is empty. If queue is empty, we are adding the very first element basically. So we will be making both f and r as 0. Okay, otherwise if it is not empty, then we'll just increment r, and finally at that location we would store this x. Okay, so that's what we had discussed in Enqueue operation. And let's then get to this Dequeue operation where we will delete an element from the queue. So insertion is done at rear end, and deletion would be done from front end, right? Yeah, शोएब शुरू करते हैं. हाँ, मतलब शुरू हो गया already. Anyway, yeah, sir. So we are discussing Dequeue operation of like which we are about to discuss Dequeue operation of queue. Enqueue we had done in the last session actually. So we'll be continuing with Dequeue, and then I'll also introduce you to this circular queue thing. So just leave me. Okay. So yeah, basically you would need to connect this writing pad thing. Just a moment, guys. I had forgotten to just plug this thing in. Yeah, now it's fine. Yeah, sorry for this. Okay. So yeah, let's take a queue. Okay, it seems like a very small queue, but anyway. So 0, 1, 2, 3, 4, 5, and 6. And let's pick up some dummy values. Let's say 5, let's say 9, let's say 7, 8, 0, 2, and 3. For example, this is our queue. So, and this is full. Okay, the actual queue might be having some more space, but this is our front and this is our rear, and we are trying to delete something. Okay, let's say size I have taken 10, so maximum I can store 10 elements in the queue. Anyway, I want to discuss your delete operation now, so let's focus here. Yeah, queue is FIFO, first in first out, so whichever will come first, like 5 would have been inserted first, so now we are deleting 5, so we should be deleting 5 first because that is at the front and that had come in the first position. Okay, so we'll be deleting this 5. So deletion would be done from front end, so we'll be deleting this 5 here. So basically what we need to check, first of all, when you are deleting, so you'll check for underflow, whether the queue is empty. If queue is empty, obviously we don't have anything to delete, right? So in that case, we'll just print underflow, or you may write no items to delete or no element to delete. So kind of that. So let's go with this dequeue operation. And yes, in dequeue operation, as we are deleting something, so we would print the item which would be deleted. Okay, so deleted item would be 5, and then we can just print the rest of the thing. So we can then delete it actually. Sorry, not print it here. So void dequeue, yeah, first of all, we need to check if the queue is empty. So how can we check for the emptiness of the queue? I'm not talking about that song or emptiness, emptiness of queue. Okay. So if f is equal to -1, yeah, if front is equal to -1, because in deleting, while deleting, we check for front. Okay, we go from front side, so that's why I'm taking F. You can also go for R, guys. Even in the last session, I told the same thing. You can also check for R if R is equal to -1, but this is DQ, and we are concerned about front here, front end. So that's why we are checking if F is equal to -1. We can just print underflow, or you can just write, okay, no item to delete, and then you can just return from this function. Okay, this is return, guys. I know it doesn't look like a return. My handwriting is not very good, but I think you understood this thing. So this is basically return, which should take you out of this function. Okay, so if it is underflow, then this would be done. If let's say f is not -1 and you are now deleting, you are now trying to delete something. So here again, two conditions comes into picture. First is, let's say we have these elements in this queue, and now we have to delete it. Okay, fine. So what we need to do? So we can just store the front element in X, and we say that, okay, this element is to be deleted. So you can basically print this X. Okay, yeah, I know the syntax will be print %ld and all, fine. And then what you can do is you can increment the F. I mean to say, next time F would be here. So you need to increment F after removing this first item. Okay, anyway, that is fine. That is fine. Or you can just combine this thing, combine this thing as X equal to Q of F plus plus. So I have used post increment. So first Q of F would be stored in X, then F would be incremented. That's fine. Okay. Just tell me, guys, just tell me here, if the Q has one element and you are performing deletion operation or dequeue operation, then will this code work? Just tell me your answer. I'm just waiting for your response in the chat. So I'll be looking for your response, guys. Just tell me this answer. Okay, you got the question right. So I've written the piece of code here for deletion. We have seen that, okay, this is working for this situation where whatever I mentioned in the screen. If the queue has only one statement, or sorry, one element, will this piece of code work in that case? Just I need your answer on this. Yeah, Varun, see, insertion would be done at rear end. Okay, so there is a queue. Any person comes in would stand behind all the person, right, at the end. So insertion would be done at rear end, and deletion would be done from front end. The person who has come first will get the ticket first and will move out first. Okay, so yeah, so this piece of code will not work when you have one element in the queue, because when you have only one element and you are deleting that element, then queue would be empty, right? So you are deleting the only element that is there in the queue. So queue should become empty, and if the queue is becoming empty, then your front and rear, this front and rear should become -1. So that thing you need to check, guys. Okay, so that thing we will check. If, and how can we check whether the queue has one element or more element? I think we have already discussed about that. F is equal to R. See, guys, there are two situations where F and R will be equal. One is when the queue would be empty, when F and R both are -1. Otherwise, another condition is when Q would have one element, then F and R will be equal. The other one, that empty wala condition, we have already checked, F equal to -1. So that condition is there. If this condition is false, and then if F is equal to R, then we say, okay, the queue has only one element. So in that case, we have to make both F and R as -1, because we have deleted the only element that was stored there. Okay, then else F plus plus. If there are more elements, more than one element, then we just go, we just increment this f. Okay, got it? Got it, guys? One thing I may have missed out, like basically here, we need to print the deleted item, right? Before deleting something, we need to print it, right? So what you can do is you can just write x equal to q of f here. Just store the item which is to be deleted. The item on the front will be deleted, so you can store that front element in x first, and then you do this if else wala thing. Then you can print this x as deleted item. So just mention a statement like deleted item is x. So this is your dequeue operation, guys. I hope it's clear. So you need me to repeat? Yes, I'll repeat. First of all, while you are deleting something, first thing we need to check is whether the queue is empty. Okay, so we'll check. So if queue is empty, obviously we cannot delete anything. Okay, so we'll come out. Okay, next. Uh, if queue is not empty, then obviously we can delete something. Okay, so we will store the front element in this variable x because I need to print the item to be deleted, and we know that in queue deletion would be done from front end. So whatever element would be on the front, I'll store that in x first because I'm going to delete it. How to delete it? So now two conditions, guys. One is the queue may contain only one element and you are going to delete it. So if this is the condition, after deleting the queue would be empty. How can you check that queue has only one element? So you can check by this comparison. If f is equal to r, both f and r will be pointing to same location. Like this, if this is the queue, okay. So both f and r, this is f. Let's say this is r. Let's say element is 2. So you can then say, yeah, it has only one element. So if f is equal to r and you are about to delete it, right? So both f and r will be -1. That means the queue would be empty again. So f and r will be -1. Else f plus plus. That is this condition. Like your let's front is 5, so you'll just increment f. Now f should point here, not here anymore, because 5 would be removed, deleted. So just increment f, and then you print that x because we had stored the front element in x, right? So just print it as a deleted item. Understood this, Savita and Rohit? Clear? Is this clear, guys? Just repeat. Okay, sorry. Respond to this, and we would be moving forward. Basically, I'll be discussing this display thing. Got it? Okay. Brish Kishore, I see your condition. Like you have written f equal to r, not equal to -1. Okay. So basically, what this f equal to r will give you, and you are checking it as not like -1. So let's say f and r are both -1. F equal to r would give you 1, and 1 would not be equal to -1. So you don't go for this way. Okay, don't compare in this way. Just write if f equal to r, and that would do. Okay, right? Okay, great going, guys. So you are following, right? So everyone over here are on the same page. So let's move on to this display thing. So let's see how we can display the queue. Displaying, I guess this display is very easy, guys. So let's quickly see this. Let me draw a line here. So display is nothing but what we do is yeah, memory. Okay, yes, Vavit. So yeah, the element will be there in the memory. We just consider that it is not a part of queue anymore. Okay, got it? Because the queue elements are considered to be from front to rear, and front is now pointing to this 9. So we consider this 9 to 3 are the queue elements now. Okay, that's what. So yeah, again, when I say we'll be printing the queue. So if I talk about this display queue function or just the display, so what we need to do, guys? Nothing. It's very simple. You just start from this front for I equal to f, and you go till rear I plus plus. Okay, and you just print this all the elements q of I. That's all. So it's very simple. Yeah, one more thing, guys. Before displaying, you also need to check for underflow. So here you need to check for underflow. So we already have written the code for underflow, this part, right? So you can just copy that thing here. First, we would check for underflow if the queue is empty. If queue is empty, obviously there is nothing to display. So we just can give a statement, print a statement like, okay, no item to display, and return from the function. If queue is not empty, then you can go for this loop. Like we'll start from front, we'll go till here and print each element. Okay. So Ankush, no, that's not the case. I'll just come to this point of yours. I was about to go, like I'll be introducing circular queue to you all. So I would basically discuss on that point. Okay. So okay, first of all, is this point clear, guys? This entire thing, whatever we discussed. Is this clear? This enqueue operation, dequeue operation, and display operation. This is all about this queue, simple queue, guys. This is the operation. So is it clear, everyone? So just respond here. Maybe just okay. I'm bored of this. Looking at this, yes, and got it clear. So let's try something else. So just put some emoticon here. Whichever emoticon you like, just put it over here. So make this chat box very colorful. Okay, make the entire chat box very colorful. Spam it with the emoticon you like. Okay, and we will move on, move to the next one. Yeah, no more yes. Okay, I'm bored with this yes and all. So okay, just fill this chat box with emoticons, guys. So whatever emoticon you like in WhatsApp and all, just fill it. Okay, and meanwhile, I'll just clear this entire thing. So I'll be taking some time to clear it like this way because and meanwhile you can put some of favorite emoticons over the chat. Okay, great. So Ravi, okay, you have put this. Okay. Oh, I thought that was mask emoticon, but anyway, that's nice. Yeah, great going, guys. Yes, I see this one too much. Great. So thank you for putting this, like making this chat box very colorful actually. So it was kind of a boring chat till now. I see now this every kind of things. Okay. So yeah. So let's try to have some discussion on this circular queue. Circular queue. Okay. What basically made us think about this circular queue? Why we are going for circular queue? That was the first question. So obviously there is some demerit in single queue, that simple queue. That's why we are going for circular queue, right? So let's understand the loophole in that simple queue. Actually, that point was mentioned by one of your friend. I don't remember the name right now. I think Ankush, something. Okay, yeah. Anyway, so here the queue is there. This is the queue, right? Right. And yeah, let's say we have some more space also. Anyway, 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So there are certain elements. Let's say size I have taken as 5. Yeah, because we are implementing this queue using array. So that would be, maybe we have taken array capacity as 50. So that is the maximum capacity. But size of the queue we have taken 5. We can only store 5 elements in the queue. So let's pick some elements basically. So 9, 7, 3, 0, 8, and 2. Okay, I have taken one extra element. Let me remove that. So here, or maybe I'll remove some more elements. Yeah, that's nice. Okay. So now this is a front, means that queue front, and this is the rear of queue, right? This is where this front and rear are pointing to, or you can say not pointing. Basically, F is 0 and R is 2. So basically, they are holding the index of the front element and the rear element respectively, right? So let's say we are, let's say we would be deleting or we are performing dequeue operation. So when you perform dequeue operation, so yeah, F would be incremented here, right? And we say this F is not referring to here anymore, and this 9 is not there anymore. So basically now f is referring to this location or index 1, that is 7. Okay, fine. Then next time we'll go for enqueue operation. So fine, let's do some enqueue operation. Okay, 5. So rear would be now here, right? Okay, got it. So now rear is not there. Rear is now at 3, index 3. So rear is 3 and excuse me, front is 1. Okay, great. So now let's say we go for one more dequeue operation. Okay, just pay attention, guys. Let's say we are going for one more dequeue operation. So when we go for dequeue operation, so front would again get incremented, so f would get shifted there. So f is not referring here anymore. So this 7 is not there. Let's again one more enqueue operation. So we'll be inserting one element. Let's say 3. Sorry, 3 is already there. 8, maybe 8. Okay, so 8 would be inserted here. So basically, R is now referring to this location and not here anymore. Okay, fine. Front is 2, and rear is 4. Okay. So next time, if I want to add one value, can I do it? Can I do it here? Obviously not. Why? Because size value is 5. And if you see the enqueue operation, guys, if you remember the enqueue operation, we are checking for that overflow condition. And overflow condition there, it is nothing but R equal to size minus 1. If R, and we know that insertion will be done at rear end, and rear has already reached the last position, like it is holding the last element already. At size minus 1 look index, we are having an element, so I cannot store any further number. So that's a demerit here, guys. Okay, that's a demerit. That's the issue with this simple queue. Even if we have spaces on the front side, on the left side, we still cannot add any more value if R has reached this size minus 1 condition. So in simple queue, efficient utilization of memory is not happening or is not being done. That's why we are going circular queue, and let's see how circular queue overcomes this problem. Okay, so are we on the same page, guys? Are all of you are with me on up to this point? Is this like very clear to you? Again, I would need this same thing. We'll continue the same thing. Like you just put emoticons here instead of this yes and clear and something. So that makes like that makes me feel like okay, we are in a classroom thing or something. So we are here in YouTube and this beautiful online medium. So let's use that. Let's be according to that. Okay. So is this thing very much clear? So you can put some emoticons there so that I would get to know. Yes. Yeah, 9 and 7. Yes, with N and 7. Yeah, 9 and 7 deleted. Yeah, that would actually not be deleted. That would be there in the memory. Yes, I understand that. We are just shifting this F, but we are considering that they are, or we are assuming that they are deleted because queue elements are from front to rear. So those elements would not be part of the queue anymore. Again, we cannot store any new element also there. So this is all about the demerit or loophole in this queue implementation, simple queue. Let's talk about now circular queue, guys, which would overcome this problem and which would use this memory efficiently. So as the name suggests, circular queue. So obviously it would look like a circle. So let me. Okay, I'm not very good at drawing. So let's try. Okay, let's compromise with this. Okay. So next time what I'll do, I'll put a bangle over my this writing pad and draw around it so that I'll get a nice circle over here. Anyway, this is circular queue. So I'll put some. Basically, this is array, right? So we are implementing circular array. We are taking example of using of array here. So we are implementing circular queue using circular array. Let's start from somewhere. 0, 1, 2, 3, 4, 5, 6, 7, 8, Okay, let's say 8. So 0 to 8, that means size is 9 basically. Size is now 9 here in the circular queue thing. Size is 9. Okay. So let's now like insert some elements there. So 9, 7, 3, 5, 8, 0, 2, maybe 1, maybe 6. So these are the elements we have inserted. So I started from this 9, so I would call this as F, and this as rear, right? So this is front and rear. Fine, okay. Now let's do one thing here. Let's now delete. Let's go for dequeue operation. So if I if I go for dequeue operation with this 9, let's say I would be calling this dequeue function 2 times. So this 9 would be removed, 7 would be removed, and F would be basically here and not there anymore. Okay, guys. So we have called this dequeue operation twice. So 2 elements from front have been removed, have been deleted. I just mean that we have incremented F. So from front to rear, the elements are the part of queue. That is from 3, 5, 8, 0, 2, 1, and 6 are the part of queue, front to rear. So here, if you see, rear has already reached the position size -1. Rear is 8. Now, if I go for Enqueue operation, now, in circular queue, it is possible to add new element, guys. So let's say I'll be adding 12. So I can add actually 12 here, and rear would actually come to this place. So it can loop around. So the elements will be stored in a circular manner. If there is a space after, even after reaching R, even after this R reaching size -1 condition, if there are spaces on the front side, R can just loop around and elements will be stored. So that's the benefit here, guys. That's how it is using the space efficiently. So if I want to add one more element, yes, I can definitely do that. So 15 would be stored here and your rear would come here. Okay, getting it, guys? Are you getting it? So this is how it goes. Okay. So obviously here the memory is being efficiently used. If you compare with the simple queue, we had here some space from front side on the front side, but we are not able to use it. Whereas in the circular queue, we are able to use the space available in the front side. 9 and 7 would be overwritten. Now that in that memory location, now 12 has been stored. So 7 has been replaced with 12, and that sorry, 9 and 7 was there. So 9 has been replaced with 12, and 7 has been replaced with 15. Okay, because we are replacing something. If you store x equal to 10, after some time, if you write x equal to 20, so obviously now x value is 20, right? So in that memory location, now 20 would be stored. So similar manner. So we are now storing 12 and 15 there. So we have lost now 9 and 7. Even we don't care about that because we have deleted that, right? So this is how circular queue work, guys. This is the benefit in using circular queue. That is why we are going for circular queue when we already have simple queue. Okay, one more thing here. So in simple queue, while insert operation or enqueue operation, we check for overflow because we need to check, right, whether the queue is full, so we cannot add any more element. And that condition was rear is equal to size -1. But here we clearly get to know that only checking this rear equal to size -1 will not give us this overflow condition because there may be space after it, like on the front side. So you guys tell me what would be the overflow condition for this circular queue. Just tell me, like, just think about it a bit. I'll give you some time. Okay, and I would need you to answer this question. I want to see how much you have understood this. So can you actually get to it? Just give me the condition for overflow in the circular queue, guys. Because only checking R equal to size -1 will not work. We have already seen this. R was already 8, but still I was able to add this 12 and 15. So what do you think in this case would be the overflow condition? So I'll wait for your answer. I'll wait for your answers. Just put your answers, guys, because we also have to discuss some more things here. So it's quickly finished. Let's finish it up. Just wrap it around to this, and we'll be going towards this competitive coding. I have some good questions to discuss. Okay, someone says if f is equal to r, so that would also mean we have single element in the queue. F would be equal to r when it would be equal to f would be equal to r in two cases. One, it can be like queue can be empty or queue has only one element. So in both these cases only this f equal to r condition will be satisfied, right? Okay. So okay, see, one condition you can be f is 0 and rear is size minus 1. This can be one condition. So basically f equal to 0 and r equal to size minus 1. If f is 0 and rear is size minus 1, then we can say it is overflow. Okay, this is one overflow. Also, if you see this case here, the q is overflow, but r is f is not 0, rear is not size minus 1. So if I talk about this case particularly, then here it is nothing but f is equal to rear plus 1. So this is another case. So you would say, okay, we have to check this two condition for overflow. Either the first one would get satisfied for overflow, or the second one would get satisfied for the overflow. Okay, but yeah, you can go for this, guys. No error or nothing wrong if you write this two condition like f equal to 0 and rear equal to size minus 1, or f is equal to r plus 1. If any one of the condition gets satisfied, then you can say overflow. But let's not write this many things. We can actually write the shorter version of this. And yet, yeah, I see Ankush has written the answer for it. Even, yeah, Ankush has written the answer for this. So actually what we can go for here is we can check actually f is equal to rear plus 1 modulus size. See how both the thing would fall within it. So when f is 0 and r is size minus 1, so in our case f would be 0 and rear would be 8, right? So what is rear plus 1? 8 plus 1, 9. 9 modulus size would be 0. F is 0. Okay, right? So this is good. So like the first condition is working here. When r is 8, f is 0, rear plus 1. 8 plus 1 is 9. 9 modulus 9 would be 0. Yeah, this is working. And next one, this thing. Okay, let's coming to this particular situation. If r is 1, f is 2. F is equal to r plus 1 modulus size. R is 1. 1 plus 1 is 2. 2 modulus size or 2 modulus 9 is again 2. Yes, that's perfect. Perfect. So even this condition is also satisfied. Right? Okay. F equal to r plus 1 modulus size. So this two condition or instead of this two condition, we can just write this one condition, and that would make sure, okay, it is either overflow or not. Got it, guys? Clear? Clear, right? Yeah, Hemalata, actually front greater than rear may not be suitable every time, because let's say we delete this item, we delete this, delete this, delete this, delete this, delete this, delete this. So where is front now? Front is here. What is front? 0. Rear is 1. Front is actually less than r here, not greater than. Okay, right? And if I talk about front is greater than r, so basically what would that mean if front is greater than r? So if I check kind of this way, so if I have q, okay, if I have a q and you are saying front is greater than r, so like so 0 1 2, 3, 4, 5, 6, 7. Okay, so one thing we got is f, when f is less than, f also can be less than r. Okay, here f is less than rear, so we can still add value. So let me get your comment back. Front, okay, you have written front greater than rear. So let's see. Also, let's go for this condition, guys. Can I clear this thing? Like, have you got this thing, this condition f equal to r plus 1 modulus size? Because I also want to get into this comment of Hemalata, this front greater than rear. So we have already seen one thing. When front is less than rear, yes, it's pretty sure that there is more space. Like, okay, it is not overflow. We can add more value. Let's get into this front greater than rear thing. So can I just erase this thing and can I get that question? Okay, so yeah, guys, so I hope this thing is clear. Yes, I see this thing is clear, so let's go there. Yeah, so I have a circular queue, and let's put some 0, 1, 2, 3, 4, 5 and 6 and 7, for example. And you're saying front, when front would be greater than rear. Okay, so maybe rear is here, and front is, okay, you're saying about talking about front greater than rear, right? I'm making always this front less than rear, so that's not that's not what we should do. So okay, maybe front is here, so we have elements like 2, okay, 2, 3, 4, 5, 6, 7, and let's say this is rear. So of course, yes, here this f is greater than r, and we still have space there. We can like add some value here, but the moment, let's say front is here. Okay, let's say front is here, so we don't have these values, okay, we would have this value, just a minute. Yeah, so we have 6 and we have 7, so f is 0 here and rear is 1. So in that case f is less than r still, and we still have you can say uh, space to add more value. But if we go for this condition, if f is, let's say, here, in this case, guys, we still have space, and f is basically not greater than r also. And so how you are going to see this condition basically? So would you be writing some other condition for this? So let's say I have started, like I have this circular queue thing here. Okay, so when we are adding the first element, 3, 4, 5, 6, 7. So when we are adding first element, let's say 10. So both front and rear is 0. So if f is greater than r, no, right? F is not greater than r, f is equal to r. Okay, so that means we still have the space, or we have still spaces to insert new elements. Fine. Okay, then now f is here. Oh, sorry, f would be not there, rear would be there. Now I'm inserting one more element, so obviously I'll have one more element here, so let's say 12. So now f is less than r anyway. So we have come up to this situation when f would be greater than r only when like we delete something, and we okay, let me get to this condition. I'm not exactly getting the position where f can be greater than r. That's what taking time. Okay, so maybe what we can do is, yeah, we can just go with this thing. So basically, yeah, rear would be here, and maybe front would be here. Okay, so rear would be here and front is here. So front is at index 7. Okay, rear is here. Can we add more value here? Just answer this question, guys. Rear is 1 here. Okay, so from 8 to 12 are the elements in our queue. From front to rear, from 7, then 0, then 1. These are the elements, right? Because we have deleted. So, and yes, here f is greater than rear. Is this overflow condition? Can't we add more element here? That's the question. That's my question to you. Just answer this. So I was just figuring out some condition where f would be greater than r, and we need to check like whether we can add more elements or not. So just you answer me. We still can add values, right? We have spaces like here, 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 and here. So might have deleted this many elements. So that's why we reach like the front reached here, got here. So basically this space, this space, this space, this space are backend. So I can take this rear here and I can add some value here, insert some value here. Next time R can be here and I can add some value here. So I think even if front is greater than rear, we still have values to we still have space to insert new value. So I think this makes more sense when we write r plus 1 modulus size. Okay, yeah, that's what. So we need to find out a generic condition where we can which would suit in every case for overflow. That's what I'm saying. Okay, so yeah, guys, so I hope we got this thing of f for f greater than r. So I was just figuring out to in which situation we can have this front greater than rear. Anyway, guys, so yeah, so it's time we would have a quiz on this queue. So yeah, Kriti, can we have a quiz here?
Sure, sir, just a minute.
Okay, guys, so quiz link has been shared. Also, yeah, Kriti, we can also put on the display the link.
Yes, sir.
Yeah, thank you. So guys, yeah, so the link is also on the screen. Also, it has been shared in the chat. Just click on that, get your quiz, answer it as soon as possible, and let me know just when you do it, so that we would continue with the discussion. Basically, would be going to this competitive coding thing. Yeah, Swami, hi. Just get to the quiz, finish the quiz, and let me know when we're done with the quiz. We'll be getting into competitive coding. Yes, guys, are you done? Yeah, okay, I got one person done with the quiz. Quickly do it, guys. Quickly do it. I'm waiting for like discussing this, waiting for discussing this competitive coding thing. Yeah, great, Ankush. Yeah, congrats. Okay, guys. So, are you done? Are everyone done with the thing, quiz thing? Because we'll be going to this competitive coding thing. Remember, we had discussed, like I had said a few questions. The first one was rotating the like print the array content after rotating it k times towards left, and that to be done in big O of n in linear time complexity. Okay, guys. So I think all of you are done with the quiz thing. So we can actually continue with our discussion. So yeah, Kriti, you can have the screen. Yeah, thank you. So okay, guys. So I hope you are done with this thing. So yeah, remember this question which I said, like some array elements are there, like 9, 7, 6, 8, 0, and 2. So these are the array elements: 0, 1, 2, 3, 4, and 5. 6 elements are there, and we need to rotate it k times towards left. So we need to print the array content after kth rotation towards left. That was the question. Okay, so for that you may need to like you'll think that okay, I have to rotate this array. So what is basically meant by this rotation towards left? So if I rotate it towards left by like first time when I rotate it towards left, so this 9 would come here. Basically, you'll the array content would be 7, 6, 8, 0. 8029, and again if I rotate it towards left, so this 7 would come at the end, so you'll get 6, 8, 0, 2, 9, and 7. So you're following, right? So after second rotation, this is my array content, and if I rotate it one more time, it would become 8, 6, not 6, sorry, 8, 0, 2, 9, 7, and 6. So this should be my output after rotating it 3 times towards left. Let's say I have taken k as 3. So that is the problem statement. And you may see here what I'm doing basically. So I'm rotating it. And if to rotate the array, what is the thing we have to do, guys? I think you might have submitted assignment answer for this. So this 7, like this 9, we have to hold like this 9 we need to bring at the end. So this 7 should be shifted here, 6 should be shifted here, 8 should be shifted here, 0 should be shifted here, and 2 should be shifted here, and 9 we have to take it towards the end. Similarly, we have to continue the step. Again, if I want to rotate it one more time, then 7 would be taken here, 6 would be brought here, then 8 would be shifted here, then yeah, so on, right? All this thing would be shifted. Okay, so for one rotation, if you see, for one rotation, we are taking big of n. So if I have to rotate it k times, then you would say, okay, this would take big of k in time complexity. And let's say k value is n. I want it to rotate it n times in worst case, let's say. So that would take this thing as big of n square. So you may not provide solution in this way for the assignment question, but in competitive coding, it has been asked, or it is supposed to submit the solution in big of n. So what exactly we are going to do? See guys, it's again very easy. You just need to think in a different way. So this is an array, and I need to print the array content after kth rotation, or okay, here k value is 3 after third rotation. So here, if you clearly see the question, they have not actually asked us to rotate the array. Just print the content of the array after third rotation. So it's very simple again. So if this is 0, 1, 2, 3, 4, and 5, if you compare this thing here, okay, we're rotating 3 times, right? So this is the array content after third rotation, right? Okay, first rotation, after first, this is the thing, after second, this is the thing, after third, this is the thing. Okay. So if you print from index 3 to 5 first, and then from 0 to 2, so that is 9, 7, and 6, are you not getting the same result here? Right? Yeah, we can say big of like n into k. Yeah, let's for k can be any value, right? So let's say k is n. So if you write here big of n into k, one might think that k is a constant here, but that's not the case. K depends on the user. So yeah, so yeah, I'm getting this point, right? So we are just printing from 3 to 5 because we need to rotate it 3 times towards left. So from index 3 to 5 I'm printing, then from 0 to 2 I'm printing, and that is giving my answer here. Okay, fine. One more thing, guys. So how many elements are there here in this array? 6 elements are there in this array. So let's say I would ask you to rotate it 8 times. Means k value is, let's say, 8. So would you go for 8 times rotation? Actually no, right? We don't have to rotate it 8 times, because if you clearly see, if you rotate it 6 times, array has 6 elements, and if you rotate it 6 times, so you'll get back the original array, the given array. You'll get back to this array. Just rotate it. Okay, let's say okay, this is after third rotation. After fourth rotation you'll get 0, 2, 9, 7, 6, 8. After fifth rotation you'll get 2, 9, 7, 6, 8, 0. After one more rotation, that is eighth time, after eighth rotation you'll get 9, 7, 6, 8, 0, 2. So basically this is the same array which was given to us. So if there are n elements in the array and you are doing, or you are going for n rotation, basically you will have the same array. So when k is given as 8 times, you don't have to rotate it 8 times actually. Basically you need to rotate it 8 modulus 6 times, where 6 is the size. Okay, so that is 2 times. So actually you need to rotate it 2 times. So I can say k modulus n times, where k is the user input, the number of times user want to rotate, and n is the size of the array. So if k is like greater than n, so I'll get a smaller value here. If k is less than n, then I'll get the same k. Anyway, okay, is this point clear? This thing. So if I ask you to rotate it 8 times, basically that comes out to only 2 times. So, and I know if I rotate it 2 times, what I have to do, I need to print from index 2 to last till the last. So 6, 8, 0, 2. Then we'll print the elements from index 0 to 1, that is 9 and 7. So this would give you the answer. Got the logic, guys? And yes, we are doing this in big O of n because we are not actually rotating it. We are just printing the array from a certain position to certain position. And again, one more part. Got this? So I'll quickly show you the code for this. Actually, I had done that. I am saving some time because if I get some more time, I'll be discussing more question. So let me share the solution with you. Just a moment. What is that? Yeah, yes. So I think you are seeing this. So we have this array. So I have taken some values here already because I don't want to waste our time into like by taking input to this array. So this is the array we have: 10, 20, 30, 40, 50, 60, and 70. And then we have this k and I. Okay. K is basically the number of rotation we need to do. I is that a loop variable. So we are taking input for K, whatever user gives. Then if you if you see here, I've written I equal to K modulus 7. So K modulus 7, why I have taken 7? Basically 7 is nothing but the size. Actually we should be taking N, but here I have taken fixed set of values. That's why I have taken 7, okay? 7 is basically the size. So, okay, yeah, sorry for it. So I hope now this should be fine. Okay, yeah, I have zoomed it. Just wait for a moment. I will show you. Yeah, I think now it should be perfectly visible. So we have this array with certain fixed elements. 7 elements are there. Then this is K, this is I. Okay, and I've taken input for this K. And if you see this loop, I started from I equal to K modulus 7. Let's say K is 3. So 3 modulus 7 would be 3 again. So I'll be starting from this 40, 50, 60, 70. Then I'll print 10, 20, 30. So that's what I've done here. From K modulus 7 till the last, I'll be printing all the value. Then from 0 to 1 less than K modulus 7. Okay. So from 0 to 2, I'll be printing the rest of the elements. That's what I've done. Why I've taken this modulus thing? I've explained already, right? So we don't have to exactly rotate K times. We have to rotate actually K modulus size times, and 7 over here is the size. So I hope this thing is clear. I'll share this, okay? You'll get this file, this code thing. So I hope it's all clear, guys. So let me like go to a different question where I'll discuss a question. You might have heard this question. I'm not very sure if I've heard or not. That is this Barua number system. Okay. So let's get there. So what basically this Barua number system is, let me get back to, don't worry about the code, I'll be sharing this code with you. Just need to understand things. Okay guys, so yeah, this is a number system given to us, which is Barua number system. And this says like, okay, there can be, yeah, this number, if any number is a Barua number, then it would contain only 1 and 0, first condition. This is first condition. Second condition is there can be any number of zeros, but only one. Okay, so there will be only one occurrence of 1, and there can be any number of zeros, and only 1 and 0 are allowed in this number. Third is first digit is or must be 1. Okay, first digit must be 1. It would contain only 1 and 0, and there would be only single 1, and the rest of the number would be 0. Okay, so like, are you seeing this basically or not? Oh, so I think that was not visible until now. So okay, I've just written this few things. What is Barua number? It would contain only 1 and 0, and then it would contain, like, it may contain any number of 0, but only one or single 1, and then first digit must be 1. Okay, first digit must be 1. So that's what uh, that number can be called as a Barua number. So this question, basically what they would say you, like, some numbers would be given to you, many numbers would be given to you, and you need to multiply all those numbers. Okay, so the question goes like this, like, there will be many numbers given, and there may be one decimal number. Maybe, okay, I'm not saying there would be definitely, but there may be one decimal number. So decimal number would be maybe 112 or 156 or maybe 5 or maybe 172100. Maybe even this can be a decimal number, right? And again, what are the example for Barua number? Like this can be Barua number, this can be Barua number, even this can be Barua number, or this, or any number of zero you can put, right? So this all can be a Barua number, and on the right side we can have one decimal number. I've written an example. So okay, these are some examples I have written for decimal number, but in the question it has been mentioned that there will be maximum, or there can be maximum one decimal number. There may not be any decimal number, but certain Barua number will be given. So either all the number would be Barua number, or one would be decimal number and rest would be Barua number. So given these numbers, you have to multiply and print the result. So this question might feel like very easy. Okay, yeah, what's there in this question? We just have to multiply these things and display it. We print the result. Fine, but maybe if you get this kind of number, let's say I have one number, Barua number, this, and I have then this number 152 decimal number. One decimal number is this. Maybe some more zeros are also there. So if you try to multiply this thing and store it, store the result and then display, so your memory will not allow you to do so. There is a certain limit in the memory. So I have taken this number. The number may be given as large as 10 to the power 18. And how many such numbers can be there? Maybe let's say 10 to the power 6 such numbers would be given to you. So multiplying this many numbers again, this like so large numbers and storing that in memory. So your memory may not allow that thing. Okay, even so that's the thing here. So how can we do this thing? Can you give any idea, guys? Can you think about this question? How to solve this question? Any number you get, so you get the output. You get the output here. I really would like you to think upon this and give some way out here through which we can answer this. The solution is very simple, guys. You just need to think that way. Yeah, guys. So I'm still looking for some response from your side. We just have to print the result of multiplication of these numbers and nothing else. We just have to print result of multiplication of these numbers. That's all. Okay. Okay, let me get to this. No, you don't have to check if the number is Barua or not. It is given that Barua number should be given and maybe one decimal number would be given. That's all. So see this, it's very easy again. If I ask you to like multiply 152000 and this, so would you really multiply this thing? You will not multiply this thing, right? It's very clear, right? Okay, I'll just say 152 and okay 3 and this 40. So 3040. This should be the result. How we did it? Did we really multiply this thing? No, right? We just counted the number of zero and we took part of this thing. That's how we answered it. So anybody, if anybody is going to ask you this question, you will directly say this. What question you are asking? This is very simple. This is the thing. So why you are not thinking in that way when you are going for programming? You just have to. You just need to do the exact thing, guys. There. Okay. So what we would do basically there is, if I have these numbers. Okay. Just let me get back to the number. What was the number I had given as an example? Yeah, these are the numbers, right? So what you do is you run like you run loop, you run a loop. Just count the number of zero from every number. So count the number of zero. Okay, this would be very. Let me take a Okay, the Barua number is given as 100, and let's say this, and let's say this one, and the decimal number is given as 152. I'm just taking few zeros here just to explain the concept. So what we will do is we will count the number of zero here, count the number zero here. So okay, here 20 here. So let's say we have a variable count. So initially two zeros. Okay. So when we count, actually when we will be counting zero, so we'll also delete that zero from this number. I think that you can do. Okay. Then we'll go for this number. So we will count. Okay. So 3, 4, and 5. So likewise we'll be counting. So how many zeros? 2, 3, 4, 5. So C value would be 10. Then how many zeros? 1, 2, 3, 4. So 14 zeros total. So we have like remove this zero from the number. So I think you can do this. So you just need to do n equal to n by 10, right? So we would delete the last digit in this way. And till what or how many times the loop would run? What would be the condition for the loop to terminate? Basically, we just have to, or we just need to count the number of zero. We should not be counting the rest of the digit, or we should not be going. We should not be removing that other digit. We just will remove zero and we'll just count the number of zero. So the condition here can be n modulus 10 if it is still, if n modulus 10 is equal to 0. If the last digit is 0, then the first thing is you can increment the count value and then remove that 0. So for every number you have to do this step, guys. For every number you have to do this thing where you will count the total number of 0. And by the time you count total number of 0, all those 0 would have been removed from all those number. And every time you count, let's say you count number of 0 in this number. Okay, let's say this number is x. Okay, so you take a variable p, initial value of p would be 1. So after this loop, what you can do is you can just multiply p into x. What is x? Basically this number. So you can actually convert this n into x every time. Okay, got it? No, it would be given, Ankush, the question it would be given that the trailing would be zeros. Okay, trailing would be zeros. It would be given. So p equal to 1, p into x, right? So this is the thing here. Yeah, even so p equal to, sorry, p equal to 1 and p into x here. So what we did here? So p was 1. Now 1 into 1 is again 1. Fine. So next time this number would be fetched and the number of 0 would be counted. So again the same thing, x would be 1. So you again will get 1 in p. So likewise even this number you will multiply 1. So when you get to this number, so number of 0 would be counted and this number of 0 would be removed. And when you now do this operation p equal to p into x, so it would be basically p equal to 1 into 152. So you'll get 152 in p. So just print this value p. So 152 would be printed and you just have to run a loop for c times and print those many zeros. So 14 0 would be printed. Okay. Just run a loop c times and those many 0 will be printed and you have written the solution for the code, the question. So the problem is solved. Okay, is this clear? Is this clear, guys? And okay, Ankush, one more thing. So there is certain limit given. Okay, let's say there is certain limit for a data type. Even if you get 1500001, whatever example, whatever number you have given, so that would be as per the constraint I said maximum value can be, let's say, 10 to the power 18. Okay, or the constraint would be given accordingly. Maximum that can be 10 to the power 6. So 10 to the power 6 minus 1 values would be all Barua number, because only one number can be decimal number. So all this will, after counting 0, all this value would give us just 1. as a result of p. So we just need to multiply the value of this decimal number, even if it is 1520000, what the maybe number of zeros are there, and 1. So we just have to store this result, right? And this would be within the limit. But if you multiply this thing, like if you multiply 100 into this, obviously this result you cannot, maybe you may not be able to store. That may go beyond the like limit. So that's what. Got it? Ankush, your query is answered or not? Yeah, Ankush, I'll need your confirmation. Is the point clear? Like based on your question 152001, if this is the number, then so will this work? Yes, this will work, because that would even that would be within the limit actually, even if you have this number. Yeah, I know I just scribbled like here and there, but I think the thing is pretty clear. Got it? Okay, great then. So let me clear this out. So I hope you can easily do this, guys, because you have already might have done this reversing of numbers, reverse the digit of the number, reverse a number. So basically the same logic here, just have to multiply this thing and remove those zeros. That's all. Okay. So this is all about this Barua number system. And yeah, one more question which I have is about this stacks and queues actually. Okay, stacks and queues, which is yeah, I guess I have posed this question. So stack would be given to you. You have to write the logic for push, pop, and find maximum or minimum, all the three operation in big of one constant time. So if you see the logic for push and pop, it is already taking big O of 1. Like it is done in constant time, because in push what we do, we just put the new element on the top. That would take constant time. If you want to go for pop operation, just remove the top element. Even that takes big O of 1 or this constant time. But if you go for finding maximum element or minimum element in a stack, you may end up scanning the entire stack like we do in array. So we are basically talking about the array implementation of stack. So we may end up scanning all the element of the stack, which would give us this big O of n time velocity. But the question is doing this in big O of 1. Okay. So let's say, so how to do this thing? Can anyone think of this? And yeah, guys, this question was asked in yeah, Amazon. Yes, for Amazon selection round, this question was there, if I remember it correct. Which year exactly, I don't remember, but yes, Amazon had asked this question. Might have also seen this question somewhere. I'm not sure if you have seen or not, but this is pretty good question. So can you think of something, guys, on this question? Like, how can we actually do this thing? How can we solve this thing? Yeah, same. So some elements are there. Let's say, what would we take? Maybe okay. Let's go with 22, maybe 25, maybe 19, maybe 18, maybe 16, maybe 15. Yeah, let's say these are the elements we got in our stack, and we need to find the minimum element here. So obviously the minimum element is actually 15. That's pretty clear when we look. But to do in the program, you need to compare with all the rest of the element, right? To make sure, okay, this is the minimum element. No, Ankush, you cannot do that actually. You are not supposed to change the stack behavior, right? Stack behavior is saying like simple. If the elements are given 22, 25, 19, 18, 16, and 15. So you need to insert in this order. 22 will be pushed first, then 25, then 19, then 18, then 16, then 15. You are not allowed to disturb the stack. Okay. How would be you like? How would you be sure, see that the minimum element would be on the top of the stack? If you run a for loop, basically you are scanning everything, right? So you will be comparing with all the elements. In that case, it will be big O of n, but the question demands you to solve it in big O of 1. That's where we need to run our brain. If you compare with all other elements, that would take big O of n. That's what I'm saying. That's the exact thing which we do in array to find minimum or maximum. We take the first element as min element. We assume that okay, the first element is minimum or maximum. Then we compare with all other element and say okay, finally we would find the minimum or maximum element. So that will take big O of n. See this, guys. Okay, let's focus here. What we will do is we will take, okay, this is the main array, let's say, and this is my one more array I'm taking. Again, I'm not good at drawing, so I'm just taking some. Fine. So 0, 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, and 6. So this is our stack, original stack, and this I would call as mean stack, let's say. So here we have top, and here we have, let's say, mean top, like top of mean stack. So this is mean top. So what is the very first element, guys? Very first element is 22. So yeah, push it. So 22, push it. Even here you have to push it because there is nothing there in this stack. So just push it. So now if anybody asks you what is the minimum value in the stack, you can say, yeah, it's easy. It's 22, fine, because it has only one element. Okay, let's insert one more value there. Next value is 25. So 25 would be pushed on this stack because this is the original stack. We are not allowed to disturb the order. Okay, but here we are taking another stack here, and that is not the, this is not the original stack. So we can do some modification here, or we can actually control in which way we need to insert here. So what we will do here is we get this next element 25, right? Before pushing 25 into the stack, we can check what is there in the top of this stack. What is there? 22. Is 22 greater than 25? The element which we are now going to push, is it less? Is it greater than the top element, like this min top element, or less than? So the new element which we are going to insert, that is actually greater than the min top. So we will not insert it. Rather, we will insert the same 22 again. Okay, we will insert the mean top once again there. Okay, I get my point. So we didn't insert 25. Why? Because 25 is actually greater than the top element in mean stack. So we are inserting the same element 22 once again because we are maintaining here minimum element, guys, in this mean stack. So always the top element should be the current minimum. That's what we are doing. Okay, right? Then what is the next element? 19. So 19 would be pushed here. Fine. And in this stack, while pushing, we'll check, is 19 less than the current top element? Yes, 19 is less than the current top. The current top is 22. 19 is less. So we would be now inserting 19 here. So min top would be here. I'm just writing empty min top. Then again, okay, next number is 18. Okay, we'll push. Okay, let's go to a different number actually. Let's not go with the 18. Let me go towards 20. Fine. So now I would now I would insert 20, let's say. So 20 would be pushed here, right? 20 would be pushed here. So is 20 greater than like, okay, sorry, is 20 less than the min top in this tag? No, right? So what we will do, we'll again push 19 here. Instead of 20, we'll push 19 because 19, the top of the element is still less than, so we'll just push this same element. Then next 16, okay, 16 is less than 19, so we'll push 16. Then we got 15, 15 is less than 16, so we'll put 15. So now if anyone asks you what is the what is the minimum element in the stack, you just pick up this top element of main stack and print it. That is the minimum element, guys. And you don't have to do this operation separately. In the same push function, you just have to add a few lines for this one to do this operation. While pushing in this stack you also have to push here, but before pushing just check this condition whether, okay, when you are pushing the first element you don't have to check anything, just push it here, push it there, fine. Next onward you have to check the element which you are going to push, is that smaller, is that less than the current minimum, current top of the stack, mean stack. If that is the condition, you can push the new element. If not, then you have to re-push. Okay, you have to push a copy of the top of the stack element, min top. Okay, right? Getting it? Ankush, I'll say why that will not work in our problem statement. I'll just come to it. See, got it? So now if anybody asks you what is the minimum element in the stack, you'll just pick out this top element of the stack and you'll say, yeah, 15 is the minimum element. Let's say we are now deleting, or we are doing pop operations. So obviously this 15 would be popped out. So you need to pop this thing also here. Okay, so you have to pop 15 from, like if you're going for pop operation, you just you don't have to think anything. You pop it from the main stack, you pop it from the mean stack, the original stack and mean stack. You just pop it. Now also, now even now someone can ask you what is the current minimum of the stack, right? So if you use variable, you'd lose that. Now 15 is not the minimum, right? So now if anybody asks you what is the current minimum, you can just pick up the top of the, okay, top of the mean stack now. And what is the top of mean stack? 16, and 16 is the current minimum, guys. So you're basically keeping track of like what is the next minimum, what would be the next minimum. Even if you pop something, our this minimum elements are in the order, so we can have already this next minimum kind of this. Okay, yeah, Hemalata, yes, auxiliary space, or I can say space complexity here is big O of n. If you remember our first session on time complexity, I had said we need to compromise between time complexity and space complexity. If you want less time, we may have to compromise with space. If you want less space, you may have to compromise with time. Okay, that's where it goes. Like we have to trade off between these two things. Okay, here space complexity is big O of n, but time space complexity is big O of 1. Clear? Pretty much clear to everyone, guys? Understood this question? Interesting question, good question. So next time if you get this question, you can easily do this, right? So you already have this push and pop logic. So copy the same push and pop, okay, and try to modify that thing as per this. So basically, you just have to think about when you're so when both the stack are empty, if top is -1, so you just push the first element in stack and also push it in the mean stack. Next time onward, top would not be -1, right? Stack is not empty, so you directly push it in the stack. But before pushing in the mean stack, you check whether stack of, so this mean stack of mean top element is less than the element you want to push. If that is the case, then you just have to re-push the top of mean stack. That's what. Yeah, minimum will change, right? Because now minimum is 16, not 15. Okay. So next, if I remove one more element. So if I remove one more element, so this is not there, this is not there. So now current minimum is what? 19. Top of in stack. 19 is the current minimum. Because the elements in the stack are 20, 19, 25, 22. And 19 is minimum among them. That's how we are keeping track of all the, like, in order, this next minimum, and all. I hope this point is clear, Ankush, why we should not go for this variable thing. Okay, that would, yes, really save space, but that would not work for our requirement. Okay, I hope this thing is very clear, pretty much clear, everyone. Right? Okay. Oh, great then. So let me clear this out. Okay, so basically, guys, I am done with the things I needed to discuss with you, and yes, it's almost time. So, if there's anything you want to ask me, or you have any doubt, you want to ask me, and there I would clarify your doubt. Even the question which we have discussed, if you have doubt on that, yes, I would be, I can discuss that. So, pretty much clear thing. So yeah, there are many questions, guys. There are many questions which may look very similar, very simple, but we need to think out of the box for those questions. And some question, what is there is you have to think it in a different way. Okay, so the more question you practice, your this your box size will increase first of all, and that too you need to think out of the box sometimes. Okay, so yeah, guys, I'm open, all open for your question. You can ask your question. So I'm there if you want to ask anything, if any doubt on this for this session. I will have it. I think there is one more session on Monday, so that's like a dedicated session for all the doubt clearing thing. Also, I would try to take up some more question maybe for competitive coding. Yeah, we haven't done trees and graphs, Shoaib, because in a short span of time we have this time constraint, so I could not pick up that. In the advanced course, we would be doing all those stuff, trees and graphs, because that really needs like time to do that. Time complexity problems explain some more problems. Okay, some more problems. So I need to think of some question right here. So let me think of some questions. So if I have for I equal to 1, and if I have I into I less than equal to, and if I've done have I done this question? Coders, have I done this question? Have I done this one? So what would be the time complexity? If required, we would be doing that, Ayan. So first of all, I'll pick up doubts actually. Basically, if you have any doubt on this, anything, if you need some more problem on time complexity to understand it better, yeah, I'll definitely do it. Yeah, just tell me like what would be the time complexity for this question? I equal 1, I into I less than equal to n. Just say. So I actually have picked topics which could be covered. Like I don't want to like touch this one topic 2%, another topic 2%, and one more topic 3%. No, that's not the way we should do. So I have picked like a variety of question, but a variety of topic, and that can like could be done. Yeah, I've not picked the entire thing. Like see. Uh, Linked list, yes, there are single linked list, double linked list, also circular linked list. Yes, that's a huge thing. Also, there are many operations, many more questions in linked list. I cannot pick all those things in a very short span of time. That would need more time. So yeah, that has been kept for advanced course, guys. Because if I to take all this, then the entire like 7 and 8 days would be only on linked list. Kind of that way it would go. I don't want to do that. So Ankush, you are saying square root of n, the base is big of n, okay. So it's basically simple, you just look at this thing, I into I less than equal to n. So it is basically I square equal to less than equal to n. So it would become, so time complexity is big of root over square root of n. Yeah, you are correct, Ankush, and yeah, Ankush, you're correct. It is root over of n. Go root over n. So yeah, guys. So okay, let's say if you are if you want some more question on time complexity, yeah, we can do that on Monday. Okay. So I hope rest of the thing, theoretical thing or conceptual thing, it's pretty much clear. So we'll be soon launching this advanced course of ours, guys. So where like everything would be discussed in like much detail. Maybe I am not able to give more time to some tiny things. So we'll be doing that. Yes, one more thing, guys. Remember in the next session also we can have a small chit chat. So technical chit chat. Okay, like I'll be asking some few interview question. Okay, so it would be kind of a mock interview thing also. So and you can also answer that in the chat box. So that would be a really interesting thing. So let's not make it a boring doubt clearing session. So you may not have doubt on whatever we have completed. So one thing is I took a note of your thing, that is uh, what is that? time complexity question, more question you need. Okay, we'll do some few question, and also I'll be doing this mock interview thing. Yeah, Ankush, project. See, instead of project, I have taken this competitive coding in DSA because you really don't have much project in DSA. You need to understand the concept and you need to understand the competitive coding. And along with that, if I add project, then again I need to cut down this more topics. So even that I won't want. So if you understand data structure concept, the data, all the data structure, then you can easily implement it somewhere. So basically operations would be same. So you need to focus more on this competitive coding. If I talk about the data structure algorithm, if I talk about the recruitment drive concerned with data structure and algorithm, so I have like keep it very specific. Okay. Yeah, Jaya, you can like yeah, doc would be preferred. Doc format would be preferred. You can submit it in doc, and you would actually get the detail in the community. The community link is just above your comment. You can also join in there, so you'll find all the detail also there. Also, you might be receiving some mail from our side if you have registered. So you might be receiving mails on from our side, like what is the criteria of this submission of this what is it assignment and all. Yeah, sorry. Yeah, so yeah, Kriti, can we have the assignment? Sorry, attendance link. They're asking about this attendance link, or it is already there. Hi, Kriti, are you there? Yeah, she's there.
Yes, sir. Thank you so much, sir.
Yeah, so they need this attendance thing. So they are waiting eagerly for the attendance actually.
All right. Okay, sir. It's there in the description box.
Okay, it's already there. So guys, yeah. So you would find that in description box. Yeah, it's already. It's also shared in the chat, so you can get to that. Yes, we'll have exam, Ankush. Definitely will be like you're having exam. You have to give the exam. Okay. Yeah, that is fine. That is fine. That is also a doc, right? So any doc format is fine. You can also upload PDF. Okay, guys. So I hope you got all your answers. So let's end the session here. It's not active. Is the
Yes,
form
sir.
not?
It's active. We can refresh it.
Yeah, okay, Moon. So you hear that, right? Just refresh it, guys. You heard that, right? What Kriti said. Yeah, so just need to refresh it one, that's all. So whenever we are stressed out and some problem happens, we also need to refresh ourselves. So you might have seen this Mangal, what is that? Mars Mangal movie, whatever. I don't remember the name. So that lady just
Mr. Mangal, sir.
Mission Mangal, yes, Mission. So she also got the refresh thing. So reboot. So we just have to reboot this thing. So I'll just say refresh. Don't reboot your system. Okay then, guys. So yeah, you'll have exam. Ankush, I mentioned that, right? You'll have
Guys,
exam.
please refresh the page. You will get the link. It's active.
Refresh, guys. Refresh. Even your system is full now. Okay. Yeah, Kashyap, Mission Mangal. I remembered now. After Kriti mentioned. Okay then, guys. So I'm just closing this session off for today, and we'll meet in the next doubt clearing session. Okay, so just one more session, doubt clearing session. Okay, so basically that would be less of doubt clearing session. If you have doubt, then we'll do that. If you don't have doubt, then we'll discuss some a few time complexity question, and we'll go for some interview based question. Okay, I hope you would also enjoy that thing. So power pack at the end of the session. Okay, climax. Okay then, guys. So I'm ending this session. Thank you very much for hearing me for this long. Let's meet in the next session. Take care. Bye bye.
Thank you so much, sir.
Thank you, Kriti.
Thank you. Guys, please do not forget to fill the attendance. It's added in the chat and also in the description box. It's already there. Thank you.
I think they have a demand which they are not mentioning, Kriti. So on the last day, they would also like you to come up on the screen.
Haha,
They
sir.
have they have just heard you behind this template.
Yes, sir. We'll surely look upon that.
Okay, okay. Thank you very much from their side.
All right. Thank
Okay
you,
then.
sir.
Yeah, guys. Bye, guys. Bye, guys. Yeah, I can close it off.